The machine component is subjected to a flexural stress which fluctuates between 350 meganewton per meter square and minus 100 meganewton per meter square. Take yield strength is equal to 0.55 times ultimate strength, endurance strength is equal to 0.5 times ultimate strength, and factor of safety is equal to 2. Here it is a common data question. It consists two questions. First question is the value of minimum ultimate strength in meganewton per meter square according to Gerber's relation is. Here the options are 1050, 824, 1500 and 1964. And coming to the second question, the value of minimum ultimate strength in meganewton per meter square according to modified Goodman relation is. Here are the options 924, 4860, 442 and 1150. So coming to the solution, we know that the Gerber's relation, which is 1 by factor of safety is equal sigma m by sigma u whole square into factor of safety plus sigma v by sigma e. So this is the Gerber's relation where sigma m is mean stress and sigma v is variable stress. Mean stress is nothing but sigma 1 plus sigma 2 by 2, where sigma 1 sigma 2 are fluctuating stresses limits. So here this stress fluctuates between 350 and minus 100, that is 350 minus 100 by 2, which is equal to 125 meganewton per meter square. And coming to the variable stress is nothing but half of the difference between the two limits. So which is equal to 350 minus of minus, that is plus 100 by 2, which is equal to 225 meganewton per meter square. So these are the two values of sigma m and sigma v. One is mean stress and another one is variable stress. And sigma u we will have to find out, and sigma e is the endurance strength, and that is equal to 0.5 times sigma u. Just substitute all these values, and here we know that factor of safety, that is equal to 2. Now substitute all these values, and from this equation we can get sigma u value, and that is equal to nearly equal to 824 meganewton per meter square. So according to Gerber's relation, sigma u is 824, and in the option the right option is B. B is the right option. And coming to the second question, the value of minimum ultimate strength in meganewton per meter square according to modified Goodman relation. Here modified Goodman relation is given by 1 by factor of safety is equal to sigma m by sigma u plus sigma v by sigma e. Again we know all the values here. Factor of safety is equal to sigma m and sigma v values are 125 and 225. Sigma u we will have to find out. Sigma e is the 0.5 times sigma u. So from this relation we can get the sigma u value, that is equal to 1150 meganewton per meter square. So in the option the right option is D. D is the right option for second question. Steel cylinder of inner diameter 25 mm and outer diameter 32 mm having thermal conductivity of 30 watt per meter Kelvin is maintained at 60 degrees centigrade and 50 degrees centigrade at its inner and outer surfaces respectively. The length of the cylinder is 0.75 meter. Here it's a common data question. It consists two questions. Here the first question is determine the rate of heat transfer through the cylinder, and here second question is determine the conductive resistance of cylinder wall. So here the rate of heat transfer through the hollow cylinder is given by 2 pi KL into delta T by Ln R0 by Ri, where R0 is the outer radius and Ri is the inner radius. And here K is the thermal conductivity and L is length of the cylinder, and delta is the change in temperature between inner and outer surface. Here all the values are there. That is thermal conductivity is given by 30 and length of the cylinder is 0.75 meter, and the change in temperature is 10 degrees centigrade, that is 60 minus 50, where the ratio of outer radius to inner radius is equal to outer diameter to inner diameter, that is 32 by 25, which gives a value of 5.7 kilowatts. Actually it gives 5727 watts, which is equal to 5.7 kilowatts. Now we will have to find out the resistance of cylinder wall, conductive resistance. So that is conductive resistance is given by 1 by 2 pi KL into Ln R0 by Ri, or even we can find out by using heat transfer also, that is equal to delta T by Q. Anyway, this is the formula for conductive resistance. So which is equal to, which gives a value of nearly equal to 0.001746 degrees centigrade per watt. So in the option, the right option is C, and for the first question the right option is A. Gas of mass 1.5 kg undergoes a quasi-static expansion which follows a relationship P is equal to A plus BV, where A and B are constants. The initial and final pressures are 1000 kPa and 200 kPa respectively, and the corresponding volumes are 0.2 m3 and 1.2 m3. The specific internal energy of the gas is given by the relation U is equal to 1.5 PV minus 85 kJ per kg, where P is in kilopascals and V is in meter cube per kg. So here the first question is, the values of A and B are, the values of the constants A and B are, and here the second question is, the heat transfer in the process is. So here are the options, and coming to the solution, first we will have to find out the constants A and B. So here we know that the pressure follows a relation, or gas follows a relation P is equal to A plus BV, where P is pressure and V is volume, and it expands according to this relation, but we know that the initial and final values of pressure and volume. So here initial pressure is P1 is equal to 1000 kilopascal and P2 is equal 200 kilopascal. And coming to the volumes, V1 is equal 0.2 meter cube and V2 is equal 1.2 meter cube. So we know the initial and final values of pressure and volumes. So that now just substitute these values in this equation, that is P1 is equal A plus B into V1, that is P1 is 1000, where A plus B into V1 is 0.2. And coming to the second one, P2 is equal 200 and where V2 is equal 1.2. So from these two relations, just on solving these two relations, we can get A and B. So the values of A and B are, A is equal to 1160 kilopascal and B is equal to minus 800 kilopascal per meter cube. So in the option, the correct option is C. C is the right answer for the first question. Now coming to the second question, we have to find out the heat transfer in the process. The heat transfer in the process is generally given by dq is equal to du plus dw. So here W is nothing but PdV. So that is dW is equal to, so V1 to V2 PdV, and du is nothing but, here U follows 1.5 PV minus 85 kilojoule per kg. So this is the relation that U follows. So here we'll have to find out first the change in work done and then the change in internal energy. First calculate the change in work done, that is W1 to 2 is equal to V1 to V2, and P is given by A plus BV into dV. So from this equation we get here VA is equal to A into V2 minus V1 plus B into V2 square minus V1 square by 2. So now substitute all the values. We know that A and we know the value of B and V2 and V1. So on the substitution of these values we get a value of 600 kilojoule per kg. So coming to the change in internal energy, change in internal energy is equal to U2 minus U1 because it is a property of the system, so that we can write it as U2 minus U1, that is 1.5 into P2 V2 minus P1 V1. So which gives 1.5 into, already we know the values of P2 V2, that is P2 is 200 and V2 is 1.2 minus, this is P1 is 200 and it is 0.2. Sorry, this is 1000. P1 is 1000 and this is 0.2, which gives a value of 60 kilojoule per kg. So now dq is equal 600 plus 60, which is equal to 660 kilojoule per kg. So this is the answer for second question, and in the option the correct option is C. C is the right answer.